All right, what is up, everyone? Good morning, good afternoon, good evening. I am your host, Charlie Shrem, and you're watching and listening another epic episode of Untold Stories, where together, twice a week, we get to dive deep with some of crypto's most influential leaders, Bitcoin's brightest minds, those who are doing really cool things and have come to our industry, and everyone really in between to understand how this movement came to be, where we are right now, where we're going. And it's kind of crazy because I was actually thinking about when this show started, where it's like the anniversary month or whatever, 3 years of the show. And I've just been spending a lot of time thinking about like how, for all you guys who've been listening since episode 1, hasn't the industry and hasn't the world or the relationship between Bitcoin and crypto, it's completely changed. Like the coronavirus pandemic was a huge like growth acceleration for all of us. It exposed a lot of things that were over promising and under delivering, but it also exposed a lot of the amazingness and the brightness that crypto is bringing. And like, even people are like, yeah, we're, crypto prices have had the 9th red candle in a row over the last, 9 weeks or 10 weeks. At the same time, like VC funding is at record levels. And as my guest will talk about today, people don't want to work in any other industry. They don't want to do anything else. Everyone just wants to do Bitcoin. They want to do crypto. And so the projects that have launched and that were successful in the past year launched during COVID, during a bull market. You guys haven't even really seen yet what comes out of the bear market, because as like my friend Brock Pierce says, bear markets are for building and bull markets are for bullshit. If you meet him in real life, he'll say like, yeah, bull markets are for bearing fruit, but like in private, he's right. Bull markets are all the bullshit kind of happens. But anyways, we have a real treat. I'm really excited to introduce you guys to my next guest to talk about a lot of the cool things that he's done in his very young life. Eric Tung. Eric, thanks for coming on Untold Stories today.
Hi, I feel really honored to appear on this podcast, actually. I've been watching some episodes and felt like it was all really great, and really would look forward to talking to you about everything I've been doing.
Thank you. I'm honored, and if anything, the show allows me to talk to people and bring them to light of what people have been doing that is so cool that very few people even know about. And just I want to give your background a little bit. You grew up in China behind like the Great Firewall. And for those who know, there still exists most apps and platforms and social media. Probably even this podcast is not available in China. And at the age of 12, over 10 years ago, you started working on a virtual private network that's still being used today called Geph, Geph. And it's a great website. I was on it earlier. What's it? Geph.io, right? Yeah, Geph.io. And still being used today in a lot of places like China and Iran, but probably also Syria and everything. And now you're launching your new blockchain. Did I pronounce it right? Themelio?
Yeah.
And listen, I look at a lot of blockchains and a lot of protocols, and I've read more white papers than anyone could imagine. It's like, whoever has read the most scripts in the world, like screenplays. I've read more white papers and have seen more blockchains that have started and failed and started and been successful, usually very early on. But what's very intriguing is what you kind of did with this, and I'm really excited to get into it. Can you tell me a little bit more about yourself? Like, what did I miss?
Yeah, definitely. I think to introduce myself, I think that I kind of had a rather different story about how I got into crypto. So it really comes back to how I got into like security and like cryptography and the whole cypherpunk stuff in general. So you are right. Like when I was very young, I think I was 11 or 12, I kind of made my first large software project. It wasn't actually a VPN at first. It was just a browser called Yasva built on Chromium. It had some really cool features, but one of it was that it had a built-in VPN, and it let people in China, where I lived, to access blocked websites like YouTube, Wikipedia, and websites like that safely and reliably. And what building this really made me realize was that by coding and by learning cryptography and learning these technologies, you can make something with tangible impacts on the world really quickly. You don't need to build a factory. You don't need
Huh.
to make sure that your machine actually fits together. You just code your ideas and you're done. And with Yasser, I gave it to my friends. They can watch their cat videos, learn stuff on Wikipedia, etc. And I could see that it immediately had an impact. And more importantly, it got me interested in cybersecurity and cryptography and the whole kind of like suite of cypherpunk technologies, right? And I was really fascinated because by building these simple cryptographic protocols like VPNs, you could achieve what seemed to me like utopian goals. Like you could protect privacy from a totalitarian government. You could encrypt data in such a way that only the person controls it, even if like everybody else in the world wants to get at it. And by the time I was 14 and I went to college, I was spending most of my free time just learning about security, doing things like I went to like PGP signing parties and learned
Oh
some
yeah.
like
Oh my
IRC
God.
chats that the Tor community ran and learned
Sure.
all about all those things. And kind of like I treated like computer security as like basically my number one hobby. And it was also then that I first encountered Bitcoin, actually. I think it was around 2013. And I learned about Bitcoin from a friend. And I found the whole idea so cool because it was like decentralized and secure in a way that none of the other decentralized things like PGP or BitTorrent was. I didn't understand things like consensus back then. I just thought, oh, this is cool. And I even had a phase where every computer I touched, I had to install a Bitcoin node on it. It was kind of absurd because I felt like I was contributing to the Bitcoin network by doing so. And I even did it to my friends' computers and computers in the school's lab and things like
Yeah. That reminds me of like a funny story. I remember this very vivid memory of it's like the one that got away of I downloaded Bitcoin software on my friend's
that.
computer, and I didn't understand Bitcoin well enough to know that the whole blockchain had to be
Yeah,
downloaded
exactly.
for his and so I had sent him 50 Bitcoin for the trans and I remember like it didn't work. It was Friday night. We were like going out somewhere and I just didn't we closed our laptops and he never picked it up again. Like many years later he did. Both of us had thrown away either of those laptops. And I remember like every year or two I just have like this like memory like maybe it's here or there. And just the other day I had like a breakthrough as I found like an email where he sent me in our old like AOL addresses like his address. So I could send him that fit. And I saw the 50 Bitcoin and it's sitting in that address still. And I'm like, oh my God, I can't
Yeah,
get it.
I didn't actually own too much Bitcoin. I just installed nodes everywhere and I polluted who knows how many hard drives with like blockchain data. So, but yeah, I was really excited about this kind of thing. And when I started my PhD program right after I graduated, I basically devoted all of my research into privacy protecting protocols like Tor and Freenet. And my dream at that time was I wanted to build a better Tor that was trustless and decentralized. Because as you perhaps know, Tor is supposed to be privacy protecting, but their whole security depends on trusting the Tor project, which centrally runs the directories and things like that. But
I
trustless and
always wondered how that
Mhm.
worked with Tor. Like when you download, I understand the concept of a
Yeah,
VPN and
yeah,
Tor, how, you have your own, internal or intranet in your house where it's like you can have all your
yeah,
computers, but once the data leaves your home and it accesses the internet,
yeah,
it's not through your internet service provider. It's not encrypted. All the data, all the
yeah,
cookies, your browsing history, but also like every footprint and
yeah,
basically it's all unencrypted. And so it takes all the data. And so we're lucky actually that the internet was built in a way where data can pass through and doesn't
yeah,
need to be like, what if the internet was built and there was a rule that all data needed to be unencrypted for like the government?
yeah.
We
I
would,
know.
that internet,
It's
we're
like
lucky. How did that even happen that we could have the internet as we know it today? That's like
absolutely.
untouchable by any government or whatever.
I think it's super cool, actually. Like, I actually wrote a blog post that touched on this in the past, which is really that the internet already is astonishingly decentralized. We have
Yeah.
the biggest social institution of the planet being essentially completely privately owned, operating on its own rules, and people take it for granted that at least you have end-to-end encryption from you to Facebook, right? And I think like that is really different from how telecom works before the internet. Right? Back in the day when people listened to other people's phone lines, the solution is to put those people in jail, not to encrypt the phone lines. And every security was managed in this top-down fashion where, the phone phreakers and stuff, they didn't expose vulnerabilities. That wasn't what people thought they did. They were just damaging the phone system and they got to be put into jail. But now we have this whole idea of kind of private internet security is totally privatized. And that's actually really fascinating. But yeah, like as I mentioned, I really wanted to build like the next Tor. And that was decentralized and trustless. And that's a really difficult combo because if you're decentralized, it's hard to have consensus. And if you want like trust, you need some authority typically to kind of give people trusted reputations, which was how Tor worked. And that was, and then I kind of rediscovered Bitcoin. And I felt like Bitcoin is perfect for building this system I wanted to build because I was really drawn to how Bitcoin has incentives. It's not just a protocol, but it's not just a cryptographic protocol, but it's a cryptoeconomic protocol. Its own incentives ensure that the miners and the nodes actually want to follow the protocol. So we don't have to trust people to tell people what software to run to make sure everybody is honest. And that really struck me. And I felt like I'm going to build my dream communication network on top of Bitcoin. And I actually published quite a few papers in that area. I think I was one of the first people to embed an ENS-like naming system into the Bitcoin UTXO graph. So it's actually, I encode the
Really?
map.
That's so cool.
Yeah, I encode like the name to ownership mappings into the UTXO graph in such a way that a thin client can just traverse the UTXO graph and get it without trusting anybody else. And I was super excited. I felt like, okay, this is one of the foundation building blocks. It's like the PKI layer, right? And I'm going to build the rest.
Why is not taken off yet? I want to use that.
Well, yeah, but right when I was developing these things, the Bitcoin block size controversy hit. Every Bitcoin forum I was on, everybody was talking about it. And that really shocked me because, I felt like in Bitcoin, I found an autonomous, trustless, self-sustaining, incentive-based protocol. And suddenly something important like the blocks filling up happens. And what resolves that has to be something that felt to me very much like politics and very much like majoritarianism. Very much like people coming around, and you have to trust that the Bitcoin community is generally good. I mean, I feel like the eventual solution they came up with, basically SegWit, wasn't too bad, but honestly, it kind of shook this whole idea in my head because I felt like, okay, Bitcoin's supposed to be trustless and self-sustaining, but ultimately the protocol is maintained by the community, and the community is not trustless. They're full of great people, but do I trust that 20 years later the Bitcoin community is going to be filled with great people?
I have an inherent mistrust of anyone who tries to have any power in the Bitcoin world.
Yeah. And so, then when I look at other blockchains like Ethereum, it's like so much worse, right? Ethereum hard forks are just like a fact of life. Every few months, the next one hits, and everybody just listens to Vitalik basically. And I started thinking, I really wanted to build a blockchain that doesn't need any of this. And I also knew that I couldn't just tell people, hey, stop changing Bitcoin, because there was a pretty good reason why things happen, like governance happens, especially when you want like a really general purpose blockchain like Ethereum. It seems necessary that it constantly needs governance, adding features, fixing bugs, this and that. But then kind of my entire research became focused on how can I build this blockchain, a blockchain that's as general as Ethereum, but more trustless than Bitcoin. And I kind of eventually hit on this idea of let's make the blockchain as simple as possible, but as decoupled from applications as possible, and therefore as general as possible. And this kind of gives eventually a blockchain that's quite different from both Bitcoin and Ethereum. I'd love to talk about it a little bit later. But that became like the subject of my PhD thesis, kind of like all the research that went into this, including like a new incentive structure for a proof of stake, a new stablecoin, like a new non-fiat stablecoin, etc. And it was about to just be my research project. I didn't actually think of I'm going to build this right now at that time. And how that happened was kind of accidental almost, which is that I was presenting my research on non-fiat stablecoins at an academic conference. And then Polychain, the crypto VC, saw me giving my talk. And they were like, we've never seen anything that's even like that. So they thought I was building a stablecoin. They didn't know my whole like Themelio. But then even just that, they felt like we're going to fund you basically. And that's how Themelio became like a production blockchain a little bit ahead of schedule. And they did our seed funding, and we built, like, I hired a team and we started building this thing at a production quality. And by now, like, the mainnet has been running for almost a year. It's a very early beta mainnet, of course.
Wow.
And there's not too much things going on it. But yeah, like that's kind of how I slid into becoming a blockchain person.
You have multiple types of tokens.
Yeah.
Some are meant to be stable. You have a very interesting thesis on stable coins, or, tokenized dollars, or if you go to like my favorite site of stablecoins.wtf, it's a great website. Anyone should go to it. You can like see there's fiat backed stable coins, crypto backed, algorithmic, and hybrid. There's a lot. Everyone's talking about this now. Everyone wants to know, like, everyone understands very early on. I realized very early on that stable coins would need to be, because you'd have like Mt. Gox dollars, and BitInstant, my company, sold more Mt. Gox dollars than it did even Bitcoin, because people didn't want to buy Bitcoin retail. They wanted to buy Mt. Gox USD to then trade in and out of whenever they wanted to. And it was these like vouchers that we'd send. It's crazy. But I have an interesting thesis about this, but can you present to everyone, like, in your view, how, if Terra Luna would relaunch today, if it could be successful, like what would need to have changed?
Well, like, I did write a blog post kind of on this subject, but I think the biggest thing that would need to change is that Luna needs a value proposition independent of UST. It needs a really strong backing, and UST shouldn't be the focus of the project, because, like in a natural, like, good economy, like the circulating cash is just a tiny part of the economy. It shouldn't be the focus of the whole thing. It should be the goods and services being transacted on here, the Luna blockchain. And I think if they do that, they'll have a much better chance of it being stable. But in general, honestly, I feel like the US dollar stablecoin space is incredibly saturated. And I think that DAI and USDC is all you need. That's what I always found. And that's why, like, with my project, the native token MEL, I don't actually like to call it a stablecoin. It's not supposed to compete with really other stablecoins. What I'm building is essentially what Bitcoin wanted to be, decentralized sound money. The distinctive thing about MEL is that, first of all, it's not pegged to the US dollar at all. Second of all, it doesn't use any kind of oracles. Like, the whole issuance procedure is as completely trustless as Bitcoin's. And third of all, unlike Bitcoin, it has a low volatility. So now, how does it do so is through a really unique mechanism that I can definitely explain. But my point is that I'm actually not that bullish about stablecoins. I think the market is very saturated, and I'm not really building a stablecoin as a result.
I understand. Every blockchain ecosystem is going to need its own internal stable asset in order for, like, that ecosystem to thrive. Yeah. So that's why, like, there is an incentive for a lot of different projects, if we're going to be in like a multi-chain world or whatever, which I think we are going to be in, for that to all be successful. But I want to dig more deep into this, because I don't think this is a stablecoin problem. I think this is a crypto utility problem. Now, Bitcoin is just trying to be Bitcoin. And for a very long time, it's not ever attempted to even do smart contracts. It's not ever attempted to do anything more than be just like the hardest sound money that's immutable and no one can reverse it. Because who knows, if you add different smart contracts, incentives could change, and then maybe the chain won't be as secure anymore. So we're lucky that we have that, and that's a great utility, and it's amazing. But crypto still does not have a lot of on-chain utility businesses that provide cash flow, except for really gaming, GameFi, gambling, maybe some insurance products, and DeFi. And DeFi is the killer app, decentralized finance. If you can build end-to-end, like where you have the folks who need access to rapid liquidity and folks who want to get that yield, if you can build businesses to like circumvent all these middlemen, but in a regulatory compliant way, you can build some cool on-chain businesses. But there's a lot of utility that needs to be built down the road. So maybe like the stablecoin utility problem is a problem of us, because like you said, the problem with that stablecoin is you need it to not be backed by Luna, or you need, what you said was you need real utility of Luna. But really what I'm saying is you need real utility for a lot of these token projects.
Absolutely, yeah.
So I'm investing in and looking at projects that are like, hey, I'm going to create an on-chain business that the profits maybe can go towards a stablecoin holder. Because then a stablecoin, instead of being like worth $1, the stablecoin is the right to $1 at the end of the year or something like that. You know what I mean?
I think things like that could work, but I feel like, again, right, I think that it depends on what you're trying to do here. I don't think trying to stack stable coins with ever more exotic financial structures is really the way to go, right? Because I think the whole problem here is really that there's a false dichotomy here. I think the false dichotomy is between, do you want sound money, like Bitcoin, or do you want stable money, like USDC? And I think that's a false dichotomy. I think that you can build an asset that's exactly what the Bitcoiners want out of Bitcoin, but it doesn't have the volatility that scares people off of actually using it in their circular economy. And so Mel's main use case is not really to extract value and speculate on some financial system. It is exactly what Bitcoin was made for. It's designed to be the hardest, most decentralized, most sound money for use as money in a circular economy. I want people to use it to buy groceries. I want people to use it to back other financial assets. It just needs to be boring.
You chose one Mel to. You chose it to be the value of, if I'm correct, like the cost of 24 hours of computation.
Yeah.
Because the value of that has remained stable over time.
Yeah. Because, and it might be surprising that it has remained stable, right? Because computation has changed a lot. But note that a Mel is not defined in terms of a certain amount of computation, but a certain time of computation on the fastest processor available at that time. So for example, 10 years ago, a Mel would be the cost of running computation on the fastest CPU available 10 years ago for a day. And now the value would be running more computation because now CPUs are faster and doing as much as you can.
Who defines that price?
And the really cool thing here about the Mel is that nobody needs to. You don't need an oracle for this. You can design a trustless mechanism that measures this with proofs of sequential work. So essentially, you can submit a zero-knowledge proof.
Oh, I see what you're saying.
Get a certain amount of work. And that's the whole reason why I made this, because I use this kind of strange metric. Because this way, the entire ecosystem can be oracle-free.
Okay. So you've taken like the Bitcoin difficulty style of like where you just make the number a lot bigger and you're measuring the cost to do that on a 24-hour basis type. Is that essentially what you're doing, how it works?
No, it's sequential computation here, right? So you're really proving that you did a hash of a hash of a hash of a hash, like a million times or something. And that can only be done sequentially one by one. And you prove to the blockchain that you've done this much work. And that can only be produced by one CPU core. You can't ASIC it, you can't parallelize it. And when people submit these proofs, the blockchain then can see who is the fastest person I've ever seen do these proofs. And that defines what a day is, right? That defines how much hashes can the fastest guy make in a day. And therefore, when people submit these proofs, the number of hashes they proved can then translate into days instead of
Yeah. And in order to build a faster supercomputer, or in order to be able to be the fastest one, you'd need to have an epic amount of investment in metals and different types of like widely available resources, but also finite amount of resources, plus manpower, plus land, plus energy. So it's like
it's like a super diversified basket.
Yeah, you've created like a CPI almost.
Yeah, exactly.
That's very cool.
And it's trustless and measurable. And the really cool thing is that once this is like the reserve currency of DeFi, the whole DeFi ecosystem doesn't need oracles. Because you want prices, just look at, Uniswap pools or something. You don't need Chainlink and oracles to tell you prices anymore, because the prices are measured against a stable non-fiat asset.
Have you backtested this cost? I'm very curious to is it published? I want to see this.
Yes, it is actually. We have like this GitHub page where we backtested this cost across like historical CPU prices, electricity prices. It's been around 30 cents. Like running a CPU it has been around 30 cents for like the past 15 years or so.
Yeah, your community is nice and strong. I see it's between the GitHub and your Telegram and all your socials. It's and you've only really done seed funding with Polychain last year or something like that. You guys are in a really great spot. Mm-hmm. This is some really cool stuff. So there are parts of the blockchain, or like you would say the constitution of it, that can and will never change, even if you've taken over the whole chain or done something like that. There are like parts of it that can never change.
But you see, the thing here is really that it's not in a constitution, because I can't just tell people not to change it, right? If the community wants to change it, they're going to change it, right? True. Instead, the whole idea is that the blockchain is designed in a way to, first of all, it wouldn't have much to change. There wouldn't be a lot of need to change. It's a very simple protocol, very much like Bitcoin. How Bitcoin is much harder to change than Ethereum, also just because there's less knobs to tune. And the second reason is also the whole use case of this blockchain is really different from other L1s. It's designed to be decoupled from applications. It's designed to be like a root of trust that you kind of build layer 2s, layer 3s, layer 4s out of, and like have a really diverse ecosystem that remotely depends on the blockchain. And what this means is that it's going to be impossible to actually coordinate a new protocol change. I like to use the internet protocol as an analogy. So right now we're talking over the internet, but the basic protocol of the internet, IPv4, it's been around since the 1980s. Yeah. And all the other protocols take it for granted. And we've been trying to coordinate an upgrade to it, to IPv6, since the 1990s.
Yeah, I remember.
And this is where I think blockchain should be. It should be so simple that all the other internet protocols take it for granted. So when somebody tries to take it over, nobody's gonna listen. All the different like embedded devices and other protocols, all these hundreds of other application stacks.
That's why, backward compatibility, right?
Yeah, and the really interesting thing here is that this also means the blockchain needs to be general purpose. So the thing about Bitcoin is really that it's really simple. It's hard to change, but because it's bound to a particular application, it constantly has pressures to change, because the blocks are filling up. This money transfer application is not doing well, right? And people want to make this application better, but to make this application better, they got to change the blockchain. That's why I'm also really happy that Lightning Network and things like that are becoming bigger on Bitcoin, because I think to have the blockchain in its right place, it has to be decoupled from the application. It acts kind of as the final arbiter, or like the root of trust in the whole ecosystem. So for example, your app might not be anything related to money or blockchains. It could be, let's say, a peer-to-peer social network that's end-to-end encrypted. And the relationship to the blockchain could just be as remote as everybody's public keys are on, let's say, a rollup that's verified on a blockchain, and everything else is off-chain. The communication's off-chain, the incentives are off-chain, everything else is off-chain. But kind of like the security critical part is backed up by the blockchain. So your whole peer-to-peer decentralized social network is safe. And when people use it, they don't think about the blockchain. And I envision kind of like the blockchain taking this role of supporting the security of all sorts of decentralized secure communication protocols, publishing protocols, etc., and just be taken for granted by this whole ecosystem. It's not, most of the logic is not going to be on chain, and most people developing on this ecosystem wouldn't even deal with the blockchain at all. And I think this is how we actually get mass adoption of decentralized security. We can't do it by pushing people into DeFi and what we now call Web3. We need to expand the horizons into all these security critical apps.
That's a really good point. That's a really, really good point. It almost makes me think about if we've crested that time when crypto and blockchain was and Bitcoin was for all of us, but now are all these businesses and projects being built for just enterprise, for just, the internet service providers of the future. Because at the end of the day, how I access the internet is through a company that we pay or something like that, or my cell phone, it's another company. So at the end of the day, it's like these gatekeepers. So, VPNs, what you built, they were very personal. Everyone someone who was using it had a reason to use it. But now with the internet, it's a little bit different. So I'm wondering if we crested that time yet. I don't think so.
Yeah, I mean, I think that the thing is also just right now, the existing L1s and the whole Web3 culture, so to speak, is really focused on just doing the things in the blockchain itself and the few applications that it makes sense where it does so. It kind of reminds me of, let's say, when the internet first started and people just thought it was, okay, it's sending packets. And, people didn't really know what to do with it, right? They didn't figure out web pages or, phone calls or anything like that on the internet.
There's so much we don't know.
Yeah, and it just feels like, but then once people really realize that this is actually like a general purpose, like kind of a narrow waist protocol that you can just innovate infinitely on top of, but not within it, that's when the whole thing exploded. So like the internet, I feel like, as I kind of alluded to, I think it's a turning point in the whole way telecom worked, right? Previously, every network we had was top down and like integrated, right? The phone system was like this international cartel of like government-backed monopolies.
Oh yeah.
And the whole system was like, everybody sat down and standardized everything, every aspect from the phone lines to the phones. And that's the next version of phone network. And 10 years later, everybody sits down again and does governance, right? And the thing is that this really reminds me of how blockchain works now. Every few months, the community sits down together and thinks, what should we do to this L1? And let's add these features. And then a new, more complex update pushes out. But instead, I think the key to actually mass adoption of this technology is you need to figure out this narrow waist, this part that supports the security and the functionality of everything else. But itself, it doesn't need to change.
Yeah.
And never innovate inside it. And I think that's the vision.
People don't study that enough. People don't study that enough. That's the game theory. That's the socio token economics behind this whole thing. The reason that we're here today. Very few people. I feel like I'm talking to an echo chamber sometimes on this show because that's the why. Why does this all work? Why are we here? How did we get here? It doesn't make sense to me so many times. I think about it.
Yeah, and I think like the key killer feature of blockchains is endogenous trust, right? That's the word I use. Like you trust the system because of its own internal rules and it incentivizes people to do the right thing. And you're not trusting people. You're trusting the design of this protocol. And that should be what we all want to build. But instead, people are just like making these really complicated protocols that honestly often have very broken incentives and then just throwing the bat to community governance to fix things when things break. And I think like that's not what this new system is about, right? If you want to trust the Ethereum community, for example, to make the right choice all the time, why not have, I don't know, the government run a blockchain? I mean, you can trust the American public too. That's also a community. That's also majoritarian, right? I feel like people are missing the point of this whole decentralization and trustless thing. It really means trusting a mechanism that's very simple and obviously self-incentivized. It doesn't really mean trusting communities or trusting decentralization in the vaguest sense.
This is so cool. Where is the state of the blockchain now? Are the tokens trading anywhere, or Is it still your mainnet is released? I'm gonna go check the Mel token.
No, like the token is not released yet. So the mainnet is released because we wanted like people to participate and test things early. But we're not kind of ready yet for like actually doing our public token sale. So we're planning on doing it sometime later this year. And it would mostly be selling our proof of stake token, actually, which is not the stable Mel token. The Mel token you can mint yourself. And you can actually get Mel now by
Yeah.
minting it, and you can participate in the sequential proof of work lottery, so to speak, and get your own Mel tokens. But the proof of stake tokens are separate because I think that the ideal properties for a proof of stake token is very different from a currency, because proof of stake tokens should be volatile. They should reflect the network value, but money should be stable and sound, right? So we're going to be selling the proof of stake token later this year. And I think like a big thing we want to do before that is really just to get more activity on the blockchain and have like a robust developer community of people excited in this completely different paradigm of using blockchain.
I'm excited about this too. This is really cool. I'm really and how you just went to a Bitcoin conference and you were presenting something that you were studying
It was
as a
actually not a Bitcoin
what
conference.
was it?
It was a conference at MIT on crypto economic research. So it was like a peer-reviewed academic conference, and I was presenting the mechanism of how I measure this day of sequential computation and how that can back a completely Oracle-free stablecoin. And that's what attracted Polychain's attention.
Wow. This is really I'm very impressed by what you're building. Do you have any um wish lists for applications that you would like to see people build on top of it?
Absolutely. I think that one of my big wish lists is essentially like a, a like public key infrastructure, because I think people don't realize how horribly broken the public key infrastructure of our current internet is. Now we all have HTTPS, things are encrypted, but all of that really relies on a very insecure, very centralized.
Oh
It's
yeah.
kind of like it combines both the bad things about centralized networks and decentralized networks. It's like it's insecure even if you trust the centralized parties. I can go on and on about it,
Oh
but
my god, yeah.
basically, like I think that actually opens up so many applications, right? If you have a decentralized PKI, then what that means is that when you communicate, you don't trust the infrastructure. You can much more easily build, let's say, decentralized social networks, decentralized, Twitter, decentralized end-to-end encrypted messengers and things like that, because suddenly you have like names that you can trust have the right public key. And I'm
Yeah.
actually kind of shocked that people don't do this as much with ENS.
Well, the problem is people have to trust the chains too much still. It's like you're being
Absolutely.
pitched on a blockchain
Yeah.
instead of you
And
saying
I
we should what were you gonna say? Sorry?
Yeah, and I think that's the whole problem, right? I shouldn't need to think about whether I trust the blockchain. The blockchain should be
Exactly.
obviously secure. But honestly, right? So for example, when I built Geph, I needed a PKI too. I could have used ENS to authenticate people. I didn't. Why? Because at the end of the day, I trust kind of like my hand-built service put into a colo more than Ethereum. I mean, who knows what crazy hack would happen on Ethereum, and maybe they'll do the next DAO hack and like mess up the governance, right? And it's so complicated to use too, and it's very geared towards their use cases. So I think this is like such a huge missed opportunity, because if you think about at the core what a blockchain is, it's trustless trust, right? What that's like, shouldn't it be obvious that the apps that need this are the security critical apps, the really life and death apps where whether this encryption is sound, lots of people count on it. But instead those apps are not doing it.
Oh,
Tor
you're
is not.
so right. Yeah.
Tor is not using it. PGP is not using it. Journalists in, I don't know, like oppressive countries, they're not using ENS to encrypt anything. Instead, it's kind of like these DeFi stuff that honestly don't need all that much.
It takes time. It takes time.
Absolutely.
Things like that will change. Um,
Yeah.
it's like would you have thought that, you know, 13 years later or whatever, people would still need VPNs?
I think people would need them more, actually.
Oh, you thought it was going to
Because,
get more controlled. Wow.
well, I think like I envision a world that is going to get more controlled. I mean, in China, it definitely became more.
I agree. Unfortunately.
And I think even here, you see kind of like the opening signs of increasing internet censorship and things like that, right? So, like, you could easily imagine a world where, let's say deplatforming really goes out of control, and American platforms are just can't host certain content, and then I don't know, they move to
this podcast would get banned.
Yeah, let's say you move your podcast, I don't know, some Eastern European country servers or in some place like that. The logical next step would then to be start filtering international traffic, right? To ensure they comply with domestic regulations, right? So like, I think like people in the West, I feel like they often don't realize how easy it is to censor things on the internet if you control it at the network. All you got to do is just to pass everything through like sophisticated machine learning algorithms, which we are getting better at, and classify the traffic into what content it is and block it. People often have this misconception that the Great Firewall is like just a firewall and just any VPN can get across it. No, it's very sophisticated. They use like really cutting edge research to detect VPNs and classify traffic into what's even in the VPN. They can guess at it by looking at the patterns.
Wow.
And block things that way. And so Geph actually my like kind of anti-censorship.
How do you do it?
Yeah, it's actually like quite clever, I suppose, like the way Geph works. And of course, a lot of it is not my own research. I would say it's more the kind of productionization of a lot of research that hasn't been actually used in practice. So how Geph works, it's actually quite easy to explain. There are two pieces to Geph. First, there's like a centralized authentication server. That's like the central point of trust. And people communicate with the server through really roundabout ways that can't be censored. So one example is that I have an Amazon S3 bucket. Right? It's just like a file repository.
Sure.
And my users, to communicate with my central server, both my server and my users just upload files into the packet and see what's in the packet. In the bucket, right? So this process is really slow and it's very low bandwidth, but it can't be censored without blocking the Amazon S3 service as a whole, because the traffic just looks like you're using Amazon. You're using any other Amazon S3 service.
Oh,
so
as long as
Amazon doesn't sell me out, the Chinese government can't do anything. They don't know it's me. And then, okay, so now that you've established this very low bandwidth bootstrapping connection, then what happens is that the central server then gives every user a different set of VPN servers. And when they actually connect to the VPN servers, they use like an obfuscated protocol that can't be classified. So it's designed to look like any other innocuous traffic. So you can't detect the VPN protocol by looking at the traffic. So now what the police would want to do is that they will register an account and get a list of servers to block. Now that's where everybody gets a different list comes in. And the really cool part is this. I have a real-time monitoring system that can detect which servers get blocked at which time. And what this means is that I can then deduce which of my users are selling my servers out to the government, because I can then detect.
Oh my God.
If I give a server to that user, within a day it gets blocked. But if I get a server to that user, it never gets blocked. So I actually have this whole heuristic algorithm that monitors everything. And then I can detect which are the Sibyls, which are the bad people. And there's actually a lot of bad people. Like they've been trying to block my system for years. And then I feed those people servers unique to them.
So let me ask you a question.
They block themselves. They never block anybody else.
What if you attributed a unique NFT identity to each of those good and bad users? And that
I think that would actually be bad, right? Because like the thing is really that
you want this
system to be permissionless. You don't want people to have to buy an NFT. Which
no. Like for your own data, I meant to say, like, because you're doing machine learning on your own now, and you're creating like you can figure out who through anonymous identities where you don't need to know the actual who, but you know who is an actual good user who's not selling you out to the Chinese government. So you can almost launch a blockchain yourself and only airdrop tokens to like good users.
You can do something like that, but
that's so crazy.
but the thing is actually like it's not like tokenized or related.
No, but it's just cool to think about that stuff.
Yeah, and the final really coolest part is this, right? So when I detect the police, they got to get new accounts, right? So now you might be thinking, okay, they can just get new accounts, and the first time they come, they can always block some servers, right? Now the problem is that they got to pay me to subscribe to this service, and to get new accounts, they pay me, and I use those accounts to buy even more servers. So they literally can't win. So like the
Game of
more they try to,
whack-a-mole, but you're a
they
very
won't.
sophisticated mole. It's great.
Yeah.
I bet
And
you're doing.
honestly, I think that Geph is the only actually VPN I know in China that I would say it's actually hard to block. The others, I would say they're either the government hasn't gotten around to blocking them, or they literally work for the government. There are actually a lot of like Chinese VPNs that basically sell their user data to the government to not get blocked. And it's a pretty wild place, I
So
suppose.
cool. This is real. Well, thank you for taking the time and teaching us about so many different subjects today. I'm very impressed about what you've got going on, and I was actually just on an investment committee meeting this morning, and we're like, we need to see what the new class of projects are that are going to be launching next year, because this is getting a little bit, bleak now. So thank you for reinvigorating us, and you're giving our listeners a lot of enjoyment. People go for long car rides, and they always tell me it's like, wow, like within 1 hour, I learned so much that I didn't know before, and I'm learning too. So thank you again. And how can my listeners follow up? Like, what's your best point of like, should they follow your Twitter to get all the links?
Yeah, I think that follow my Twitter, join the Discord, and really just stay tuned, because recently we're also going to be releasing a lot of documentation for our smart contract language, Melodion, which is really different from Solidity. And it really reflects kind of our vision of how layer one apps should be like. And I would really love interest and discussion about that, actually. So
Very cool. Thank you so much.